Assalamu alaikum everyone, it's Mr. Fahad. Today we will continue with the first lesson in chapter 3. We will be talking about differentiation, and the first lesson is about tangent lines and velocity. By the end of the lesson, we will learn how to link the slopes of secant lines and tangent lines, and then how to write the equation of the tangent line to a graph at a given point using limits. And last, we will find the average and instantaneous velocity at a given point. Let's start with the main concept here. So if you have 2 points on a curve and you want to find the slope of the line connecting these 2 points, we call it a secant line. In this diagram, you can see Q and P, and the secant line slope here is given by the equation for the slope y2 minus y1 over x2 minus x1. You can see here, if you started with q, so y2 minus y1 over x2 minus x1. All right? Now, if we want to approximate the slope at point P, which is the slope of the tangent line, we will be getting closer and closer to point P, and the h value, which is the distance between A and A plus h, will get smaller and smaller. This way, we can approximate the slope of the tangent line. So once again, if the h value is getting smaller and smaller, so as h approaches 0, the secant line approaches the tangent line at the point P. And the slope of the tangent line will be the slope formula, but when h is approaching 0. So the slope of the tangent line at A is given by the limit when h is approaching 0 for the slope formula that we derived just now from the diagram. Now, to find the equation of the tangent line, since you have the slope, you only have to substitute in this formula. So y equals the slope of x minus a plus f of a. Of course, this will be on the form y equals mx plus b, the slope-intercept form. All right, so in this example, we've been asked to find the equation of the tangent line for the function y equals x squared plus 1 at x equals 1. Well, I know most of you will solve using the calculator, so let me solve this using the calculator and then I'll do it with steps. So in order to write the equation of the tangent line, we need to find the slope, and the slope is the derivative at the point given. So using our calculator, shift and integral, you'll get the derivative, and then you can write the expression that you have, the function itself, so x squared plus 1 at x equals 1, and that's it. So 2 will be the slope of the tangent line at the point x equals 1. Now, to solve this with the steps, we will be using the limit of the slope when a is 1. So substitute 1 plus h in the function. It will be 1 plus h squared plus 1 minus f of 1, which is 2. And you have to expand this. This will be the first squared plus 2 times the first times the second plus the second squared. Okay, and then plus 1 minus 2. Now just simplify the expression. You will cancel 2 minus 2 and you'll be left with 2h plus h squared. Take h as a common factor. Cancel it out with the denominator and you'll be left with 2 plus h. At h0, this will be 2. This is the same value that we got using our calculator. So you can see it's way easier using the calculator here. We need to find the equation of the tangent line. That's why we will use the formula y equals m x minus a plus f of a. We found f of a, which is 2, and then just substitute in the formula here. This will be y equals 2, the slope, x minus 1 plus 2. And now just distribute 2 and then simplify the numbers. Y equals 2x. So here's the graph. As you can see, the tangent line is the line y equals 2x. So this graph will help you understand the situation here. All right, moving next. Similar example. Find the equation of the tangent line, and I encourage you to pause the video, try to solve it using your calculator, and then come back to check your answer. So again, just use shift and derivative, write the function at x equals 1, and the slope will be negative half. And since you have the slope, you can find the equation. Now let's do it with the steps. So the limit of the slope, you will substitute 1 plus h in the function, and this will be 2 over 1 plus h plus 1 minus 2 over 2 over h, and 2 over 2 is 1, and you can simplify this to 2, so 2 over 2 plus h minus 1. Now to simplify the top, you have to multiply and divide with 2 plus h. So make it to the same denominator, and now we can simplify the top. So simplify the top, these will cancel out, and then the bottom of the numerator will go in the denominator. So you'll be left with negative h in the top and h times 2 plus h in the denominator. You can see you can cancel out h and h. You'll get negative 1 over 2 plus h. When h approach 0, this equals negative half. Now we have the slope of the tangent line. We can find the equation of the tangent line using the formula that we have. Well, at x equals 1, the point will be 1 and 1. Substituting the formula, m is negative half, x minus 1 plus 1, the y coordinate here, and then distribute negative half in the expression here, and you'll get negative half x plus 3 over 2. Here's the graph to help you understand the situation, and excellent work if you solve the question correctly. All right, so now let's talk about the average and instantaneous velocity. The average velocity is basically the slope between 2 points, which is the slope of the secant line between the 2 points in time. All right, so the difference here in distance over the difference in time. Now, to find the instantaneous velocity, if you think about it, it will be the slope of the tangent line at a given point. So the instantaneous velocity is the limit when h approaches 0 for the slope of the tangent line. Now remember, the velocity here is the speed with the direction. So if it's negative, this means it's in the opposite direction.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
All right, so once again, the average velocity is the slope between 2 points in time. But the instantaneous velocity is basically the slope of the tangent line at 1 point in time. Let's practice with an example. In this example, the height of a falling object in t seconds after being dropped from height of 64 feet is given using this distance function. Find A, the average velocity between t equals 1 and t equals 2, and B, the instantaneous velocity at t equals 2. All right, so let's try to solve this using our calculator. I encourage you to pause the video and try to do it on your own. With the first one, the average velocity between these 2 points is basically the slope formula. So y2 minus y1, let's substitute t equals 1 first, and this will be 48. And then we can substitute the second point, and this will be 0. So the slope here between these 2 points will be S2 minus S1 over 2 minus 1. So 0 minus 48 over 2 minus 1, which is negative 48. Again, the negative here means that the velocity is in the opposite direction. And for the second question, the instantaneous velocity at t equals 2. Using our calculator, this means the derivative basically at x equals 2. Again, the instantaneous velocity is the slope of the tangent line, which is the derivative at x equals 2. So equals negative 64. Substituting the value 2 here in the function, so 2 plus h, this will be 64 minus 16, 2 plus h squared, minus s of 2, which is 0. And in here, you have to expand this. So 4, the first squared, plus 2 times h, which is 4h. And then you have h squared. And now you can just distribute negative 16 inside, and then cancel out the values here, 64 minus 64, and take h as a common factor, cancel it out with the bottom, you'll be left with this expression. So the instantaneous velocity at 2 equals negative 64 minus 16 times 0, which is negative 64 feet per second. Again, it's the velocity, it's negative because it's in the opposite direction. If you did this correctly, great work. Let's move to another example. In this example, we have to determine whether there is a tangent line to the function y equals absolute value of x at x equals 0. So the first thing to do here is to rewrite the absolute value sign as a piecewise defined function. You can see when x is positive, it will stay x. If it's negative, it will be negative x. So we will try to find the slope of the tangent line from both sides when h approaches 0 from the right side. So the limit of h approach 0 from the right side of the definition or the slope, f of 0 plus h, meaning under the absolute value, this will be h under the absolute value, minus f of 0, 0 under the absolute value is 0, over h. And then since we are looking at positive values, then the absolute value of h is h. And this will be limit of 1, which is 1. Now from the left side, substituting the same formula, and the absolute value of h when h is less than 0 will be negative h. And here you can see we have limit of negative 1, which is negative 1. So the limit from the right is different from the left. This means that the limit does not exist. So if there is no slope, this means that there is no tangent line. So the tangent line itself does not exist at the corner here. And this is the case whenever we have the intersecting point of any absolute value function. All right, let's move to the last example. Okay, in this example, again, we have to determine whether there's a tangent line, and we have a piecewise defined function, and we are investigating at the point of intersection. So pause the video, try to do it using your calculator, and then come to check your answer. Okay, the slope of the tangent line when x is less than 0 is basically the derivative at 0 for the expression that we have here. So just write the expression and you can see that the derivative is 0. And now from the right side, if we wrote the expression at 0, I can see that the derivative or the slope of the tangent line is different from the left side. This means that there is no tangent line. Alright, so let's do it using the formula. We are looking around 0. So the limit when h approach to 0 from the right side, we will substitute 0 plus h. When h is positive, then we will use this formula. So 3h minus 2. You can see here when x is larger than 0, right side. And this will be 3h over h, which is 3. Now from the left side, we will use the other formula. So h squared minus 2 from the left side. And then this will be simplified to 0. And you can see from the right side, from the left side, it's different values. So 3 from here, 0 from here. This means that the limit does not exist. This means that there's no tangent line at this corner again. If you managed to solve the question, great work. That's all for today. Thank you so much for watching.